let's get down to business. I'm not going to take it easy on you because I don't want you guys to have to watch 1,000 hours of video here. We're going to graph y equals 2 minus tangent of x over 2 minus pi. Right? Now all these transformations that we talked about with sine and cosine, they're the same exact transformations. Alright? It's just going to transform a different looking graph. But the process for this is going to look kind of similar in the early going. Okay? This is our phase shift. Now it's not going to determine where we put points, because remember, tangent really only has one point. It's got two asymptotes, and it's got one point that's supposed to fall directly in the middle. Alright? So what this is going to do is this isn't going to move the left and end right point of tangent. It's going to move the asymptotes. So instead of talking about finding the left end point and the right end point, which we've been doing for the past few days, we're going to be taking x over 2 minus pi. We're going to set that equal to negative pi over 2, the left asymptote. Then we're going to do the same thing. We're going to take x over 2 minus pi, and we're going to set that equal to the right asymptote. So this still dictates how spread out the graph is and where it locates that first period, but it's not moving points, it's moving asymptotes with a tangent graph. Okay, so if we go to solve this like we did the other day, if we see fractions, let's multiply it by 2. Right? Clear everything out. So when I multiply this by 2, that goes away. When I multiply this by 2, I have negative 2 pi, and that's equal to, when I multiply this by 2, we have just negative pi. When I add 2 pi to both sides, I have x equals pi. Now this, again, not an endpoint, the left asymptote. Okay, it was negative pi over 2, now it's pi. Same thing over here, we're going to end up in a similar situation. We're going to have x minus 2 pi equals pi after we multiply everything by 2, right? Add pi to the other side, x equals 3 pi. Alright? Now, we don't have to worry about change in x, because all we used delta x for was to figure out where to put those 5 critical points on a sine or a cosine wave. But again, for the how manyth time here, tangent doesn't have critical points. It's got asymptotes and one intercept in between them. So now that we've figured out where these asymptotes are, we're almost done with this problem, believe it or not. So, we've got asymptotes at pi and 3 pi. Now I don't have graph paper here, so you're just going to have to go with it. Alright? Let's say we want to make our scale pi. So my first intercept is going to be here. That's at pi. Then I've got 2 pi. Here's 3 pi. So 2 pi is right here. Now what does a tangent graph do? Right? What does a sine, like we always used to say, what does a sine graph do? Intercept, max, intercept, min, intercept. What does cosine do? Max, intercept, min, intercept, max. What does tangent do? Tangent has asymptotic behavior, and it starts down here and rises up. But these transformations are going to mess with that. How? What does the negative do? And again, I'm not worried about y coordinates so much. What does a negative do? Flips the graph over. It reflects it over. So now instead of this tangent graph going this way, it's going to vertically reflect, and it's going to do this. Right? So that's the vertical reflection with that negative symbol. If we had a number here, if we had a number for the amplitude, what would it do? It would stretch it, right? If it was a number greater than 1. The 2 is a vertical shift, and that's where we have to get, where we have to really know what we're doing. That intercept point, remember, is supposed to be in the middle between these two asymptotes, and it's supposed to be on the x-axis. However, if we shift up 2 units, I'm going to shift that intercept point up 2 units. And that intercept point was where that behavior changed before, if you remember. It came up, it hit that intercept, and then it would bend the other way. It's still going to do that here. So I'm still going to have this be the point where the graph quote-unquote turns or bends its behavior. But remember, this one is reflected, so it's going to do this and this. And tangent is a periodic function, just like sine, just like cosine. So how do I replicate the rest of this? Well, what's the length of the period? Length of the period is 2 pi, from pi to 3 pi. So every 2 pi, I'm going to put another asymptote. So here's pi, move 2 pi units to the left. That's negative pi. I'm going to have another one of these tangent curves. Then move 2 pi units this way. This is negative 3 pi for that asymptote. Put another point. I've got another tangent curve. Okay? So we flip if this is negative. We move the intercept with this up or down. It's really the only thing we move. Okay? This takes care of the left and right asymptotes. This is how we graph a tangent function. I'm not going to show you 1,000 other examples. Just understand what these transformations do and understand that this sets the asymptotes instead of the endpoints. We're going to move on to cotangent now. It's going to go quick. Click.